So where did we stop in the last class? We were talking about the collection API. So we have gone through list interface and the ArrayList class. So we saw like what data structure it implements. Today we'll see the other things in the collection hierarchy. Okay. Yes. You see, we've got list interface. List interface is implemented by vector class. List interface is implemented by vector class. Vector is on the collection class. You know what? ArrayList and vector, they both implement the same data structure. ArrayList and vector, they both implement the same data structure. These two classes, they implement the same data structure. So what is the difference between ArrayList and vector? Yes. So is anyone familiar with the difference between ArrayList and vector? ArrayList class and vector class? So vector and ArrayList, they got some similarities. You can just make a note of these points. ArrayList versus vector. I can say that these two collection classes, they implement the same data structure. Please make a note of it. That is the first point. These two collection classes, they implement the same data structure. ArrayList and vector classes, they implement the same data structure. Yes. Next, you know, vector objects, vector class objects, I can say, are thread safe. Vector class objects are thread safe. Vector class objects are thread safe. So how about what is thread safe here? Let's see. Before that, I can say that ArrayList class objects are not thread safe. ArrayList class objects are not thread safe. ArrayList class objects are not thread safe. So what is a thread safe object? You can make a note of it. At any given point of time, only one thread can operate on a thread safe object. At any given point of time, only one thread can operate on a thread safe object. Okay. At any given point of time, only one thread can operate on a thread safe object, I can say. So what do we mean by that? What does that means? What does that means? We'll discuss, you'll understand this thread safe object concept in the thread programming. You'll understand it in the thread programming, I can say. Yes. You'll get a clear idea of what do we mean by thread safe objects and all at that time. But as of now, just make a note of it. Okay. So these are the main differences, I can say. You'll find that, okay, though this is not a big difference, but if you want, you can do that. Okay, you can just make a note of it. What is it? You will find that vector class is a legacy class. Vector class is a legacy class. It was introduced in earlier versions of Java. It was introduced in earlier versions of Java. Vector is a legacy class. It is introduced in earlier versions of Java. Whereas ArrayList was introduced in later versions of Java. ArrayList was introduced in later versions of Java. Now we'll go through the methods of vector, yeah. Vector class is introduced in earlier versions of Java. That means in the beginning versions of Java it was introduced. Okay, it was there from the very beginning of Java. Okay, whereas you'll find that ArrayList is introduced in later versions of Java. Okay, that is another difference. Now I want you people to just check this methods once and tell me. Just check this methods. And what is something special about this methods? Yes. What is special about this methods here? Yes. Do you see anything different here? Yes. You will find that all the methods of this vector class are synchronized. All the methods of this vector class are synchronized. So what is the synchronized methods means? What does it mean? Yes, you'll come to know about it. As of now, you can also make a note of it. Actually, the synchronized methods has got something to do with thread safe objects again. They've got something to do with thread safe objects, I can say. Okay. Now, I want you people to check these methods. You see, just go through these methods. It's a legacy class, as I told you people. It's an old class. So you see the methods, if you keenly observe these methods, you will find that the method names are very lengthy, right? Method names are very lengthy. Yes. see, for example, if you see that you can check this method, set elemented. Set elemented is same as set method. The same as set method. So we have used a set method in the last class, right? To add an element at a specified index. Set method was used to add an element at a specified index. You see, we have remove elemented method is the same as remove method. Remove elemented is same as remove method. Okay, so the insert elemented is same as add method. You say add element. So these are old methods. You see, the method names were lengthy. That is what I can say. That is what I can say about this methods here. Yes. Okay. Okay. Now, let me show you people one interface here which is really interesting. Let's see what is it. So I'll change this ArrayList class to vector class. I'll change ArrayList class to vector. Okay. Say I want to read the elements from this collection. So in the last class we have gone through an interface, right? What is that interface which we can use? Iterator interface, and we also saw another interface subtype of iterator. What is it? List iterator, right? So we saw iterator and list iterator interfaces in the last class. But you know what? Here, before iterator interface, there was another interface prior to iterator. There is an ancestor to iterator also, I can say, which is actually called as enumeration. So in the vector class, you can use this enumeration. You'll find a method in the vector class called as elements. You see this method elements. So if you call this method elements, it returns enumeration object reference. So what is this enumeration? Let's see. Okay, enumeration. Just a minute, please. Sorry. You see, enumeration is very much similar to your iterator. Enumeration is very much similar to your iterator. Okay. You see these methods which you have here. Can you people relate these methods to the iterator methods? You should be able to easily do that. Yes. Try to relate these methods. Yes. Come on, it's easy. Actually, enumeration is very much similar to your iterator. It's you know almost similar to your iterator. The methods you see has more elements is same as which method has next. You can make a note of it if you want. Has more elements is same as has next. And next element method is same as next method. Same, almost same I can say. Same. Okay, next element method is same as next method. Has more elements is same as has next. That's it. Sorry. So hope you people got it. Now let's use this enumeration You see, if you want that enumeration object reference, so first of all, you have to call this elements method. So it returns enumeration object reference. It returns enumeration object reference. Now we can use this enumeration to iterate through that elements. While yeah, you see. So let me run this code. That's it. So is it clear for you people? You see, has more elements. If we call it, it will check whether there is any element after the cursor. So if it finds it, if there is any element after the cursor, it returns true. Otherwise, it returns false. That's it. Similarly, we have next element method, which is same as next method. When you call this next method, next element method, it returns the element which is placed after the cursor, and also it will move the cursor. It will place the cursor after the element which is written. Same. There's no difference. Okay. Yes, almost same. That's it. So this was an old, interface enumeration, I can say. Yes, that's it. Okay, this is what I can say about your vector. This is what I can say about your vector here. Yes. So anyone got any questions in this regard, please let me know. Okay, good. Now you see, there is a subclass for vector. There is a subclass for vector. So what that is stack. Stack is another class which extends vector. Stack class, it implements stack data structure, I can say. Stack class, it implements stack data structure. Okay. So is anyone familiar with stack data structure? Can you people talk about stack data structure? Yes. First in, last out. Yes. Or last in, first. First in, last out. Or last in, first out. Yes, that's right. So let's talk about this class. So actually this class implements stack data structure. We'll see the data structure once. So we got some terminology also which we use here. Yes. What is the terminology? You see, first of all, when we talk about the stack, you'll find that always the elements in the stack, you'll find that yes, they will be added from one end, that is from the top of the stack. The elements to the stack, they will be added from one end, that is from the top of the stack. So you'll find that you see the elements in the stack, they are placed one on top of the other. You see, the first element which is placed in the stack is at the bottom of the stack. On top of that first element, we have this element 2 placed. So the second element which is added here is element 2. The third element which is added here, it is element 3, so which is on top of stack now. So always the elements are added from one end, that is from the top of the stack. And the terminology which we use here is this: adding an element to the stack, to the top of the stack. I can say adding the element to the top of the stack is called as push. Adding an element to the top of the stack is called as push. Reading the element from the top of the stack is called as pop. Sorry, not pop. Removing the element from the top of the stack is called as pop. Removing the element is pop. Reading the element from the top of the stack is called as peek. Reading the element from the top of the stack is called as peek. Reading the element from the top of the stack is called as peek. Okay. Yes. So these are the three operations. So let's check this stack class once. You see, stack it extends vector. Stack it extends vector. In the stack class, we have this push method to add an element to the top of the stack. So we have pop method to remove the element from the top of the stack. We got peek method to read the element from the top of the stack here. Yes. So empty to check whether the stack is empty or not. And then we have search method to search an element. Now how is the search method different from the method? There is a search method in the collection interface also. Did you people remember? Can you people tell me the name of the method which is used to search the elements? Give me the name of the method in the collection interface we saw that, which is used to search the elements. Contains, that's right. Contains method is there, no? Yes. So what is the difference between that search and the contains method? So what do people think? What is the difference between search method and contains method? Yeah, you see, that's right. The contains method will take an element, it will search for that element. If that element is found, then it returns true. If the element is found, it returns true. Otherwise, it returns false. Okay, that is what the contains method does. For a search method, it will take an element, it will search for that element. If that element is found, then it returns the index of that element. Search method here in this case, it returns the index of that element. Okay, so that is what search method does. So hope you people got it. This way, you see, we have this stack class which implements stack data structure. You see, it provides appropriate methods to work with stack. It provides appropriate methods to work with stack, I can say. Okay, you know what? I can say that actually we got an application of stack data structure. So we saw one application of stack data structure. Can you people tell me what is it? So what is the application of stack data structure? Yes. Yes, that's right. So in the memory management, we saw that, right? You see that is stack data structure. We have used it for stack memory. So we got runtime stack, stack memory, or we say compile time stack, right? Yes. Yes. Uh, in the runtime stack or stack memory, which you saw in the memory management, it is an example for that. Okay. Yes. Fine. So this is about your stack class, which implements stack data structure. That means internally you'll find that the elements are stored into stack data structure, and you can use this methods. Okay, so let's move on. So now the last data structure which you got here is linked list. So we got a linked list data structure, I can say. So linked list not a data structure, I'm sorry, it's a class. First of all, linked list is a class. That is what you need to understand. Linked list class, it implements which data structure? I can say that linked list class actually it implements doubly linked list. Linked list class it implements doubly linked list data structure. Doubly linked list data structure. Okay. Now doubly linked list you'll find that in the doubly linked list you'll have nodes. You got something called as a node. Each node you can divide it into three parts. Number one is previous. Number two is data part. Number three is next part. Okay, so you'll find that here this previous part, it holds a reference to the previous node if there is any. It holds the reference to the previous node if there is any. The data part, it holds that element. You can store the elements into that data part. It can take that elements, I can see. Okay, and the next part, it holds a reference to the next node. The next part here, it holds a reference to the next node, I can see. So this way, you'll have nodes. Each node is divided into three parts. So let me show you people. You see down, we have this doubly linked list. So we have nodes. We have nodes here. Okay, yeah, just a second. Let's say these are the nodes which you have here. These are the nodes which you got here. Just assume that we have the nodes till 99. That means you have 100 nodes, let's say. You see, the first node will have the reference to the next node, holds the reference to the next node. And the second node will hold the reference to the previous node. The same is the case for the second node. Now you see the second node has got the reference to the first node, which is the previous node of the second node. And second node also has got the reference to the third node, which is actually the next node to the second node. That is how it works. So I can say that the doubly linked list here, it supports sequential access. Sequential access, I can say. It supports only sequential access. Sequential access. It only supports sequential access. So what is sequential access? Can you people tell me? What is sequential access? Can you people tell me? Yes, that's right. That's right, exactly what you people said. For suppose if you want to access the third node, if you want to access the third node, so first of all we have to go through the the second node first. Sorry, first node. Then you'll get the reference to the second node. Then you'll get the reference to the third node. Because you see, the first node holds the reference to the second node. The first node, it holds the reference to the second node. And second node in turn holds the reference to the third node. So this is how it works. This is how it works here. Okay. So hope everyone got it. It will be null. First node will have previous part which will be null here, I can say. It will be null. Sorry. And the last nodes, next part will be null. Sorry, actually I didn't mention this details here. I'm sorry. So this is previous link. This is data, and this is next. This is how it works. Okay. So hope you got it. So sequential access, you see, if you want to access, let's say in a collection we have 100 elements, and I want to access the 100th element, then we have to traverse through how many elements or how many nodes here, I'm sorry, how many nodes we have to traverse through, how many nodes. If you have 100 nodes and you have to access the 100th node, so you have to traverse through how many nodes? 99 nodes, right? Yes. Okay, fine. So this is about the doubly linked list. Next, you know what, here there is one more thing which I need to tell you. If you want to add an element or a new node in the middle of this doubly linked list, then what you need to do, it's pretty simple, you see. Okay, I got a new node. Let's say we got a new node here. Now I want to add this node after the first node. It means I want to make the second node. I want to make this node the second node. So what to do? I want to make this node the second node here. Okay. So yes, that's right. So what we need to do is here, first of all, all you need to do is just change the references here of this nodes. Change the references of the first node. After the first node, you want to add it, right? So you have to change the references of first node and existing second node. Change the references of first node and existing second node, I can say. So what you need to do is here, the first node's next part should be referring to the new node. Yes. And the new node's previous part should be referring to the first node. And the new node's next part should be referring to the existing second node. Now it becomes the third node, existing second node. And the existing second node's previous part should be referring to the new node. This is the changes which we need to do here. This is how we can add a node in the middle. Okay, yes. So, so here you see, if you compare this feature of adding the elements in the middle of the collections, you know, then unlike ArrayList, I can say that we don't have a overhead of moving the elements. Unlike ArrayList, we don't need to move the elements. Am I right? Do we need to move the elements? Are we supposed to move the elements here? Yes. Are we supposed to move the elements? We don't have to do that, right? So we don't have to do that. Yes. Yeah. So we don't have an overhead here, but in case of ArrayList, we have that overhead, right? Now, what do people think? Doubly linked list, it is better for what operations or which operations, and ArrayList is better for which operations? Yes. Can you people tell me? ArrayList is better for which operations, and doubly linked list is better for which operations? Search for ArrayList, right? Yes. Search operations are faster compared to ArrayList. Sorry, compared to linked list. Search operations in ArrayList are faster compared to linked list. And whereas adding the elements in the middle of the collection or deleting the elements from the middle of the collection, in that case, you see, linked list is better. In that case, linked list is better. So hope you people got it. So with this, we are done with this list type collection classes. Okay. Now I have a question for you people. For suppose, let's say you got a requirement. So what is the requirement? You've been told to sort the elements of this collection. You've been told to sort the elements of this collection. So what you'll do? You've been told to sort the elements of the collection. So what to do? I want to sort the elements, I'm sorry. Sorting the elements means, you see, in this case we have string objects. How will you sort them? They are string type elements, right? So we can sort them in the alphabetic order or dictionary order, right? You know what? We don't need to struggle much in this case when it comes to string objects. So what we can do is here, you can use a class called as collections. You can use a predefined class called as collections. So collections is a predefined class. In the collections class, we have this sort method. This is not interface. We have collection interface. That is S is not there in the interface name. Only collection interface. This is collections class. This is also a util package. You call the sort method and pass the object reference here and pass the object reference. Yes. This is what I'll do. Okay, pass this collection object reference. That's it. Okay. What it does, the sort method will sort the elements and it will store them. It will shuffle those elements itself. That's it. Let me run this code. You see, are these elements sorted? Can I say that they are sorted? Can I say that this elements is sorted? You can check this once. Yes. Now at this point of time, you need to know more details about this sorting process. In order to sort the elements, first of all, we have to compare the elements, right? In order to sort the elements, first of all, we have to compare them. Yes. We need to compare the elements. Yes. In order to sort the elements, first of all, we have to compare them. Yes. Here, the comparison logic to compare these elements, where it is defined. Can I say that it is defined in the sort method? Can I say that it is defined in the sort method? Actually, it is not in the sort method. Comparing the elements is not in the sort method. So we have a different concept here. We got altogether a different concept. Yes. So what is it? This is where you'll come to know about comparable and comparator interfaces. Okay. Yes. Comparable and comparator interfaces here. Yes. That's right. So you need to know about these interfaces. So these are the two interfaces which we need to talk about. Okay. These are the two interfaces which we need to talk about. So I want you people to go through this interfaces. Please go through this interfaces. So in Java, to write the comparison logic to compare the objects, in order to compare the objects, we can write that comparison logic in the comparable, by implementing the comparable interface, I can say. In Java, in order to write the comparison logic to compare the objects, we use this comparable interface. We use this comparable interface. In the comparable interface, we have a method called as compare to, which we need to override. Okay, we use compare to method, which we need to override. Yes. So when we talk about objects in Java, we can broadly classify them into two types: objects which we can compare and objects which cannot be compared. Objects which we need to compare and objects which cannot be compared here. Okay. Yes. So that is how we classify these objects: comparable objects, objects which are not comparable. So, but we'll discuss about it in the next session. So I'm sorry, actually today is the last day of my stay here. So we have reception today. So uh, I have mistaken gave you the schedule by mistake, uh, to take the class for you people. Every day I didn't tell you people. Uh, I've been traveling half hour every day to a different place. Uh, as I told you people, it's my niece marriage. So uh, I've been staying, I'm alone staying in a different place, my uncle's place. So every day I attend that functions, marriage, whatever it is, and then every evening I'm coming to this place just to take the class for you people. So I stay night at here, and again I'll be traveling. So this is the last day. Please, excuse me. So by tomorrow afternoon or by tomorrow evening, I'll come back. So today's last function or party which I need to attend. So, but I will compensate your session. We'll have a class on Sunday evening for you people. I'll definitely take the class for you people on Sunday evening. So it has been very tight schedule, but I'll give you the time. On Sunday, we'll have a class at the rate 6 p.m. Central Time. Okay. So we'll continue a discussion of this concepts in that class. Okay. We'll continue a discussion of this concepts. That's it. Thank you. Okay. Sorry. Please try to understand. So it's not distant relation. So she is my elder sister's daughter. So I've been really tight, but I don't want to miss taking the classes for you people. So every day, so I've been traveling every morning. I'll go there, okay, attend all the stuff, and just come back and take your classes. So thank you. Just by tomorrow, I'll be done with everything, and I'll be at my place by tomorrow evening. So again, we can have our regular sessions properly. Thank you all. Bye bye. Thanks for understanding.